Welcome to Enteral Nutrition. This is one of the most important applied math skills you'll use as a dietitian, and you already have everything you need to succeed. We've been building toward this moment from the start of Module 1. If you understand dimensional analysis and percentages, you can write and evaluate tube feed orders with confidence. And we're just introducing the math here. You'll get even more practice in Module 4. So you'll have plenty of time to practice. You will absolutely see some math-based EN or TPN questions on the exam, but the good news is the exam is multiple choice. That means if you can get close, you can likely find the correct answer. So let's start with a clear definition. Enteral nutrition is the delivery of nutrients into the stomach or the small intestine. It's used when a patient can't meet their nutritional needs by mouth, but their gastrointestinal tract is still functioning. And so you'll hear enteral nutrition referred to as tube feeding, EN, or feeding via an NG tube, a G tube, or a J tube, depending on where the tube enters the body. In the math section, we do need to understand the two basic types of enteral feeding schedules, and those are bolus feeds and continuous feeds. In bolus feeds, nutrition is delivered in larger amounts, typically several times a day, through a syringe or a gravity bag. This is a method that's great for patients who are mobile and don't need feeding while they're asleep. So patients who are at home or those who are transitioning off full-time continuous tube feeding, bolus feeding is an excellent option for them. In contrast, continuous feeding is delivered slowly over 24 hours through a pump. It is continuous, it's always running. While continuous feeding limits mobility, it's easier on the GI tract and it reduces the chances of intolerance. So depending on if the problem gives us a bolus feed or a continuous feed, we'll need to approach each slightly differently, but the math stays the same. So let's talk about how we structure enteral nutrition math. The goal is to turn the nutritional needs into a feeding plan, and that's what tube feed recommendation really is. We do this in 3 clear steps, where we first determine the goal volume, then we calculate the total nutrition that's provided by that goal volume of feed, and then we state our recommendations. From the patient's estimated calorie needs, we calculate how much volume of formula the patient will need to meet those needs. We do this through dimensional analysis, when we convert calories to milliliters based on the amount of calories per volume of the formula. This will tell us the total milliliters of formula needed per day. And if the patient is receiving a continuous feed, we can then use the equivalent statement 24 hours in a day to get the hourly rate in milliliters per hour. Because then once we know the target volume, you can determine how much nutrition is provided by that target volume of enteral nutrition. And so when we're talking about nutrition for enteral, we definitely need to figure out the total amount of calories that the tube feed provides. We need to look at the amount of protein that is provided. We also need to calculate the amount of carbohydrates, and we always want to calculate the amount of free water. We'll find the amount of protein in grams, and carbohydrates we'll also find in grams. For water, we'll find the amount of milliliters that we need, and for calories, we'll find it in kilocalories or kcals. And we get these numbers by scaling up the nutrient profile of the formula, which is usually provided per liter or per carton to the total volume that we're giving the patient. We can find the amount of fat provided by the enteral nutrition, but it's not usually a requirement when we're coming up with our recommendations, but we'll see some problems with and without it. So this step checks whether the volume we calculated in step 1, this target volume or this goal volume, whatever you want to call it, actually meets the patient's need for protein, hydration, and calories. So once we've checked that, we can then state our recommendations. This is the clinical application part. The RD exam is probably not going to ask you to write a full recommendation because it's a multiple choice style test. It's more likely to ask you how much protein is delivered or what volume is needed to meet calorie goals. But in clinical practice, stating the full recommendation is essential. So if we have a continuous feed, we would name our tube feed and the rate. We would state the total volume that it provides, which is our target volume right here, the total amount of calories that we get, the total grams of protein, and the milliliters of free water provided by the feed. If we're giving a recommendation for a bolus feed, the recommendation works very similarly, where we give the name of the tube feed, but instead of the rate now, we'll give the number of bolus feeds. We'll give the volume per bolus to give the total volume, the total calories, the total protein, and the milliliters of free water. But let's not get ahead of ourselves. Enteral nutrition is built on percentages and dimensional analysis, nothing more. That's why we emphasize those two skills in this course and why you are absolutely capable of mastering this. So let's try an example problem. In this problem, we have a patient who has estimated needs of 1,750 calories per day. Due to the MNT that we'll talk about in Module 4, you've decided to recommend a 1.5 kilocalorie per milliliter enteral formula. It provides 59 grams of protein per liter, 190 grams per liter of carbohydrates, and we're also told that this has 75% free water. We need to meet the 1,750 calories per day estimated needs. So, to do the math, remember, dimensional analysis and equivalent statements. The first thing that we need to do is to determine the goal volume. And what that means is that from our estimated calorie needs, we're going to calculate our target volume, our goal volume of enteral nutrition, by converting from calories to milliliters of formula. This is dimensional analysis. And our equivalent statement here is the enteral formula itself. This 1.5 kcals per milliliter is an equivalent statement. Those two things are equal to each other. So we can write it out as two fractions. We can say, if we were to take in 1.5 kcals, then we must have been administered 1 milliliter of formula. Or if we're administered 1 milliliter of formula, then we're receiving 1.5 kilocalories of nutrition. And this patient needs 1,750 kilocalories every day. So since I want to convert from kilocalories, kilocalories goes in the bottom, and we'll use this equivalent statement right here. These two fractions are equal to each other, but we want kcals on the bottom so that it cancels out so we can convert from total calories to milliliters of formula. So this patient needs 1,166.7 milliliters of this formula every day. Since this patient is fed continuously, it's helpful to know how many milliliters an hour this is. And so we need another equivalent statement that tells me in every one day, there are 24 hours. So we're converting from days into hours. I want to get rid of these days, which means days is going to go into the numerator so that days cancels out. One day is 24 hours, which means we need to feed this patient 48.6 milliliters every hour. I was taught to round when I do enteral and parenteral calculations, so I would call this about 50 milliliters per hour. And we're feeding this patient continuously 24 hours a day, so that would be about 1,200 milliliters every day. Remember, the RD exam is multiple choice, so round or don't round, it's up to you. Okay, so that's step one. We determined our goal volume, which is about 50 milliliters an hour, which is 1.2 liters every day. The next thing that we needed to do then was to determine the total nutrition provided. So that means we want to figure out how many calories, how many grams of protein and carbohydrates, and how much free water is administered to the patient from this tube feed. So when we look at the givens, we're told the milliliters and kilocalories equivalent statement that we used in step one. But when we're given the amount of protein, it's given per liter. So we're going to have a problem that this is in milliliters. We'll have to convert milliliters into liters to do that. Same thing with our carbohydrates, 190 grams per liter. But we're giving more than 1 liter. We're giving 1.2 liters. We're giving 1,200 milliliters. And then we have a percent here for the free water, 75% free water. So to walk through this, let's look at calories first. This is the equivalent statement that we'll be using for calories. I'm going to write it out as an equal sign, again, that there's 1.5 kilocalories in every 1 milliliter of formula. And since we are giving 1,200 milliliters of formula, we can use the equivalent statement 1.5 kcals per milliliter to cancel out milliliters. That means we're giving 1,800 kilocalories per day, which meets the patient's needs of 1,750. Excellent. But for protein, the equivalent statement is 59 grams of protein are in 1 liter. So we'll need to convert 1,200 milliliters into liters. Milli is an equivalent statement that you should know for the RD exam. There's 1,000 milliliters in 1 liter. So if we write that out as 2 fractions, milli goes in the bottom so that it cancels out and we can convert to liters. We have to convert to liters because our equivalent statement tells me how many grams of protein in 1 liter. So once we know how many liters of enteral nutrition we are giving, we can convert from liters to grams of protein. Liters cancels out with liters, and there's 59 grams of protein in every 1 liter. So if you take 1.2 and you multiply it by 59, you'll figure out the total grams of protein administered every day. Okay, so try to figure out how many grams of carbohydrates are administered every day. We can use the equivalent statement that there's 190 grams of carbohydrates in every 1 liter of tube feed. So we've already figured out how many liters of tube feed we're giving, and we got that by converting milliliters into liters because there's 1,000 milliliters in 1 liter. And so again, we are administering 1.2 liters every single day. To convert from liters to grams of carbohydrates, we'll use this equivalent statement, write it out as 2 fractions if you need to, but we want to get rid of liters. So liters is going to go into my denominator. Every 1 liter provides 190 grams of carbohydrates, which means this tube feed provides 228 grams of carbohydrates. There is no fat provided in this tube feed, so we can take a look just straight at our free water. This is 75% free water, and we are giving 1,200 milliliters here. So we can do a little bit of algebra here to solve for how much water are we giving. Divide both sides by 100. It's percent, meaning of 100. So we get 0.75 is equal to my amount of water that we're actually giving, specific outcomes. I'm just going to write S over 1,200 milliliters. And if you'd like to make that liters, you absolutely can. So to solve for my variable S, I need to multiply both sides by 1,200 milliliters to get it to cancel out on the right side. And we come up with our answer. We should get 900 milliliters as the amount of specific free water that we are administering. Now, keep in mind, 900 milliliters of free water is probably not meeting this patient's needs. The general rule we use is 1 milliliter per kilocalorie unless otherwise specified. And so if this patient needs to take in 1,750 calories, then they probably need to take in 1,750 milliliters of fluid as well. So if we're only giving them 900 milliliters of free water, then we'll need to get them extra water. And there's quite a few ways for us to do that. But that's not what we're looking at here. Right now, we are just looking at the math. So we figured out the total nutrition provided, and now we're going to bring it home by stating the recommendation. We need to know the name of the tube feed, which we don't have in this problem, but we do know how many milliliters per kcal. The formula is 1.5 milliliters per kcal. We are giving it at 50 milliliters an hour, providing a total volume of 1.2 liters or 1,200 milliliters. And that together gives 1,800 kcals. The total protein here is 70 or 71 grams of protein and 900 milliliters of free water. So those are the skills that you need for tube feed orders. And with more practice, these are going to get easier. So keep working at it, and I'll see you in the next part of this lesson.